In this tutorial, we'll take a look at an example of changing from standard form, and this is in standard form for this parabola right now, into a factored form. And this example specifically involves some fractions. They don't always, okay, but this one does. So that's the purpose of this particular example. So, well, we can factor this using well, any method you can factor a trinomial. I'm going to use the decomposition method. If you want to use something else, the rest after you factor will be the same. So, in order to factor this by decomposition, I would need to find two numbers that add to -2 and have a product of -24, because 3 times -8 is -24. And so those numbers would be -6 and +4. So we would rewrite this, 3x squared term first, -8 still in the end, but we would change the -2x into -6x plus 4x. That's why it's called decomposition, because we're decomposing that linear -2x term into -6x plus 4x. And then we would factor by grouping. So there's a common factor of 3x here, so we factor 3x of the first two terms. 3x squared divided by 3x is x. -6x divided by 3x is -2. And we can factor a forward of these, leaving an x minus 2 as well. So the x minus 2 will factor out, and then what's left is 3x plus 4 for the other factor. Now, I'm going to rewrite it with the 3x term first and the x minus 2 second, just because that will make this next part a little bit easier, better. So that's the only reason. It really doesn't matter what order you write your two factors. And remember, factored form looks like this. It's y equals a, x minus r, x minus s. Some people use p and q here instead of r and s. But the important thing here now is that these are 1x's. Okay, see I have a 1x here, but this is a 3x. So that's actually the stretch factor, the a. So that 3 needs to be factored out of the 3x plus 4. So you might look and say, well, 3 doesn't divide into 4 evenly. So how do we factor it out? You see, if that was a 6 or a 12 or a 30, that would be just straight normal common factoring. So what we do is we're going to multiply this by 3 over 3. Now 3 over 3 is the same as 1. 3 divided by 3 is 1. So I'm multiplying this by 1, so it has the same value. It's the same parabola, same equation. Okay, we graphed it, look, these two, they look the same. And the idea is this. You see, the 3 over 3 is the same as 3 times a third. Okay, if I multiply 3 by a third, if you want to see this, 3 is the same as 3 over 1. So when I multiply the 3 by the 1, I get this 3. When I multiply the 1 by the 3 on the bottom, I get this 3. So they are certainly the same thing. So what I'm going to do is change that 3 over 3 into 3 times a third, and I'm going to leave this 3 out front, and I'll multiply the 1/3 into this binomial. So the 3x gets multiplied by a third, so it'd be 3x over 3, and 4 times the third is 4/3. So now, so that's what we just did. We left the 3 outside, we multiplied the 1/3 in, and then we want to simplify the part that can be simplified. 3x divided by 3, of course, is x. The 3's divide out to give you x there. So it changes into, so okay, this was our factored form here, but this is the actual factored form where you can see the intercepts. So these are actually equivalent, just this is written in the true factored form with the stretch factor, the a factor out front. So it'd be y equals 3, x plus 4/3, x minus 2. So one of the intercepts, one of the roots, one of the zeros is a fraction. So we're going to continue this on the next page. So there's the same thing I had in the bottom of the previous page. And so we're going to set each factor equal to 0 to find the x-intercepts. That's what you do in factored form. And so if we set the x plus 4/3 equal to 0 and the x minus 2 equals 0, and of course we want to solve for x. So if I solve this for x, I'll just subtract 4/3 from both sides, or some people say move the 4/3 over, it becomes negative. So x is -4/3 is one root. And the other one is 2. And I'm going to, I'll show where those are on the graph. Of course, -4/3 is -1/3, so it's going to go through the x-axis. Actually, maybe I'll put a dot right there. Approximately right there. And x equals 2, it's going to go through there as well. So now what we're going to do is we're going to use these two x-intercepts, or zeros, to find where the vertex is. The vertex is a very important point in graphing a parabola. It's where it turns. It's either its highest or lowest point. A is positive, so it opens up. We're going to have a minimum point for our vertex. And we can use the add the roots and divide by 2 to find that axis of symmetry. If you haven't seen this abbreviation before, that just stands for axis of symmetry. So we're going to add -4/3 and 2. So add them together, divide by 2. Now this 2 here doesn't have a common denominator with the 3, so what I'm going to do is I'm going to multiply it by 3/3. Again, I'll have my denominator of 3 up for both, so I can add the fractions. So 2 times 3/3 would be 6/3. That's where the 6/3 comes from. And so if I add -4/3 and 6/3, that gives me 2/3. So this is 2/3 on top, still dividing by 2. We haven't actually divided by 2 yet. And see, that 2 is of course the same as 2 over 1. So I will change this into taking the 2/3. Instead of dividing by 2 over 1 or 2, I will multiply by the reciprocal of that 2 over 1. So it's 2/3 times 1/2. So if we multiply that, see, 2 times 1 is 2. 3 times 2 is 6 in the denominator. And of course you can divide 2 into both of those, and you get 1/3. So that is the axis of symmetry. X equals 1/3 is the axis of symmetry, and so that's what it looks like. Goes through at 1/3, so you see that would be about half, so it's a little bit below the half. And so this also means that that's the x-coordinate of the vertex. The vertex is on that axis of symmetry, so the vertex is 1/3 comma something, and we're going to find that y value of the vertex by substituting the 1/3 into the equation. And we could use this form or the original form or that factored form in the middle we had. It wouldn't matter. They're all going to give the same thing. I'm just going to use the original one. So I'm going to put 1/3 in here and here. So that's what it looks like. So when I square the 1/3, in the numerator 1 squared is 1, and in the denominator 3 squared is 9. So we're multiplying 3 by 1/9. 2 times 1/3 is 2/3. Okay, so 2 times 1 is 2 in the top. There's a 1 underneath the 2 here. 1 times 3 is 3 in the denominator. And kind of looking forward a little bit, see, I have a denominator of 3 here. So this -8 doesn't yet have a common denominator with what's going to be over here. So I'm going to multiply by 3 over 3. Right here, the 3 times 1/3, see, that's 3 over 1. When I multiply this 3 by this 1, that's 3. And 1 times 9 is 9. So that actually will reduce to 1/3. We're going to have 1/3 there at the beginning. So this is 1/3, this is 2/3, this would be minus 24/3. 8 times 3 is 24. So 1 minus 2 is -1, minus 24 is -25/3. So that's the y-coordinate of the vertex, -25/3. This is how we write the vertex. 1/3 is the x, -25/3 is the y-coordinate. Now, well, how do you plot -25/3? Well, you could change it into a mixed fraction or a decimal. I'm going to do both. 3 goes into 25 8 times with 1 left over. So that's actually -8 1/3. So we could write this as 1/3 comma -8 1/3. So over 1/3 and down, you see that's 5, 6, 7, 8. And about 1/3, so the vertex is going to be about right here. You could also change that to a decimal. 1 divided by 3 to 1 decimal place is 0.3. It's actually 0.3 repeating, so I'll round it to 0.3 for the sake of graphing. And this would be -8.3. Again, that point about right there. So we'll put our dot there. That's the vertex. So our parabola is going to open up. Now, instead of just drawing it with those 3 points, I'm going to use the step pattern to get a few more points to draft this a little bit more accurately. So the normal step pattern for the standard parabola that has not been transformed at all is the 1, 3, 5. And since A is 3 for this, or this, doesn't matter which one you look at, then we would multiply the 1, 3, 5 by 3. So 1 times 3 is 3, 3 times 3 would be 9, 5 times 3 is 15. That's going to be too big as me off the top of the graph. We won't be graphing that one here, but we can do the 3 and the 9. So if we start at the vertex here, so we go over 1 and up 3, from the vertex over 1 and up 3, there's 2 points. And then we'll do the same thing with a 9 from these. I'm going to go over 1 and up 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's a point right there. And of course, you do the same thing over here. Over 1, up 9 is going to be the same height as that one. So that's the over 1, up 9. And of course, the 15 is off the graph, so we won't worry about that one. So I'm going to draw my parabola through those. Notice it went very nicely through the 2 dots I plotted for the intercepts. So that's what y equals 3x squared minus 2x minus 8 looks like. So I just wanted to do an example that involved some fractions in it. And that's how you, if you have a factor, like the 3x plus 4 we had back on the previous page, that's how you factor the stretch factor out and then write it in a true factored or intercept form. And that's the end of the tutorial.